Hello everyone. Good morning.
Good morning.
Morning, Ashish.
Good morning, guys. Okay. How many? Okay. Only 9 people. Let's wait. Meanwhile, inside distribution. Okay. Today we'll see the simulation in NumPy. Great. Okay. Sampling from continuous distribution. This is what we are going to see today, right? I told you like 4 types of things, but we'll try to cover 1 or 2.
Yes, Ashish.
Yeah, let me see. 14 people. Okay, 13 people. Okay. Okay, let me start because we have to cover so many things. Okay, so yesterday's recap. So we saw different type of distribution, normal distribution, exponential distribution, their properties, how this looks like in terms of plot, what is the mathematical equation for those distributions, and what are the mean and standard deviation. So those things. Now the concern is like if you have a population data that we can't use that much data, so we'll take samples, and the samples should look like similar to its original population data. That should be our aim here, so that we can infer that sample and take meaningful insights from them. So first technique of sampling from population is called inverse transform sampling, but here there is mathematics behind it. Let's try to understand what is first in first place. This method involves generating a random variable from a uniform distribution. Okay, so this is the first step. And why we need to generate the variable from uniform distribution? That is actually the answer lies in the mathematics, which I have given here. And I'm not going to explain this one because those who are interested on the mathematics part, how this got derived and what the procedure, why we're following the procedures, this is the answer here. Okay, and it's not required actually in this session to describe these things. If you want lots of videos, and this notes also is going to help you, so I'm not going to explain this part. But yeah, the first step is to generate a random variable from uniform distribution. Okay, so if you want to take some sampling from a normal distribution, or if you want to sample the data from normal distribution, first step is to you generate a random variable from a uniform distribution. Okay, and then using the inverse CDF, cumulative distribution function, of the target distribution to transform into the desired distribution. Now what does this mean? That means here if you see, one term is called target distribution. So target distribution means from which distribution we want to collect the sample. That is my target distribution. Suppose I want to take a sample from uniform distribution. So that is my target distribution. So two type of distribution we are using here. If you see, one is target distribution, one is uniform distribution. Two things. So first we'll generate some random variable from uniform distribution. Then after generating the variables from that uniform distribution, we are going to do inverse CDF of our target distribution. Suppose normal distribution. So we'll use the CDF formula of normal distribution, and we will pass this generated variable that we generated from uniform distribution. And then we'll see how that distribution that we sampled by using these two steps, first step, then second step, how that looks like. Let's do that. Okay, let's simulate that in NumPy. Let's try to achieve the same using NumPy. To generate a random sample from standard normal distribution using inverse transform sampling, we do the following. See here, this is the aim here, to generate a random sample from standard normal distribution. Now here one catch is there. Okay, do you know what is a standard normal distribution? What is the difference between normal distribution and standard normal distribution? Anyone?
Double type curve.
Square of variance, I think.
Sorry, square of?
Square of variance.
No, actually. See, guys, normal distribution is something like this, right? Normal distribution, something like this, bell-shaped curve. What do we mean by standard normal distribution? So that means this is standard normal distribution is also a normal distribution, but here there is a catch. Okay, and this is a interview question, guys. Okay, you have to careful about it. There is in statistics or also in DAs, you have two concepts. Any field you go with the data you have two things. Okay, you have to normalize the data or standardize the data. This is called data pre-processing step. That means why we do normalization, why we do standardization, because to make our data vary inside or put inside in one unit. Now suppose, for example, that's why I'm going very slow and explaining each bit, guys, so that it will be helpful for you to clear the basics. Suppose this is your data set, okay, and this is your data frame containing different columns with data. Now in one column I have measurement, okay, distance measurement in centimeter. One column I have distance measurement in millimeter. One column I have distance measurement in kilometer. Now if I'll measure one unit of data, 1 kilometer equal to 1000 meter equal to 1000 into 100 centimeter, 10 to the power 5. Now if you see here, these three columns and these three data are exactly similar, but the value is changing according to what? The units that we are using. Now as a human, we can distinguish this difference, but machine is not going to distinguish this difference. Machine will consider this as 1, this as 1000 times of 1, this is 100 times of thousands. So machine will calculate this one is the higher priority because it's the highest number. Machine will not understand, okay, this is centimeter, this is kilometer, this should be equal, right? So this type of issue, make it every value that you have in your column into similar unit. Okay, so what we do, either we standardize or normalize. So what happens when we do that? Every value will be between 0 to 1. We'll make this every value inside every column between 0 to 1. How we will achieve that? Now what we'll do?
Binary.
Not binary. Standardization, normalization, and standardization. Okay, two different, like two similar kind of concepts, but conceptually these are a bit of difference in mathematics. So suppose consider this one. Okay, consider the centimeter column. I am writing cm. Okay, this column I have let's say not 10 to the power 5, let's say 10, 20, 30. Okay, like this is my data. Suppose let's 3 data. Now what do we mean by I'll normalize this column? What I will do in normalization, the formula is this every element, that means xi minus x mean divided by x max minus x mean. This is a formula for normalization. That means what we'll do, First of all, we'll verify what is the maximum number, what is the minimum. The minimum is 10 here, maximum is 30 here. Okay. Now here with every element, we'll do the same. That means we'll do it 10. 10 minus x mean is what? 10. X max is 30 minus x mean 10. So this is becoming what? 0. Then again, we'll do the same thing with 20. What we'll do? 20 minus x mean. That is what? 10 divided by 30 minus x max minus x mean. That is 10, right? So this becomes what? 10 by 20. That is what? 0.5. Again, we'll repeat this for 30 also. 30 minus x mean. That is what? 10 x minus max x mean. That is means 20. So this is 1. So this 10, 20, 30 now becomes what? 0, 0.5 and 1.
Ashish, anything 0 divided by anything is equal to infinity, right? According to basic mathematics.
Sorry, there is some noise. I lost few of your words. What you
No,
said?
no, what I'm trying to tell you here is 0 divided by anything is equal to infinity according to basic mathematics.
No, not. No. 0 divided by something is 0. 0 divided by something is 0. Something divided by 0 equal to infinity. Isn't it?
Okay.
Yeah. So, your understanding is like if 0 is at the numerator, that is not a problem. That is 0. 0 should not be at the denominator. If that will happen, that means infinity.
Okay.
Because this is normalization. Okay. And again, similar concept of standardization. Now, how I'll make you understand, let me use eraser here. I'm going to erase because same thing I'm going to explain you with the same example. But here we put normalization. Now, what is standardization? Okay, let me just. So standard here, if you see this term standard normal distribution, okay, that means we are applying standardization here. Okay, so what do we mean by standardization? Now standardization formula means xi minus mu divided by sigma. In normalization, what we are doing? Xi minus x mean divided by x max minus x mean, that is normalization. Now standardization means for each point, now what is the mean value from this data? 10 plus 20, 30 plus 30, 60 by 3, that is 20. So mu equal to 20, right? Now what is the standard deviation?
Square root of variance.
Square root of variance. So what is variance like? I need to calculate the standard deviation. How I'll calculate here from here? 10 minus 20 square plus 20 minus 20 square plus 30 minus 20 square divided by 3.
1 minus 1.
3 minus 1, right? This is what? 3 minus 1 or 3, guys? What is the formula? N or N minus 1? Are you sure for a standard deviation we do this?
Yes, sir.
Right. Okay. So what is the value here? This is 0. This is 100 plus, and this will be root over of this, right? So this will be 100 plus, this is also 100. 200 by 2, that is 100, that is sigma equal to 10. Okay, mu you calculated 20, sigma it comes as 10. Now what do you mean by standardization? Take each point 10 minus mu 20 divided by sigma, what is that? 10. Then for 20 also you do the same, 20 minus 20 divided by sigma. Then for this also you do the same, 30 minus 20 divided by 10. So if we'll perform this, whatever value you will get, that is your standardized value. Okay. So
but Ashish will get the negative value in this, right? Don't we?
So that this value will be from -1 to 1. So here we are calculating this 10 as -1, then 0, then 1. So if we'll normalize, what was the value? 0, 0.51. If we'll standardize, what is the value? -1, 0, 1. So this is my new value after normalization and standardization. Those are two things. And also you have to remember the formula, because someone will ask you, what is the normalization formula? What is the standardization formula? So here, standard normal distribution. Now, if you calculate here, can you tell me, if you calculate here, what is the mean of this three value?
Zero.
And what is the standard deviation? See, the quickest way to calculate the standard deviation, after you found the mean, see the nearest number to this. What is the difference between them? That is the standard deviation usually. So here, if you see, we calculated standard deviation came as 10, but quickly you can calculate from here. What is the difference of every number from mean? 10, right?
10, yeah.
That's why quickly you can say 10 without doing all these things. Similar concept will apply here. What is that means? What is one, right?
Yeah.
Okay. So that means if you standardize any data, the mean of the data will always be 0 and standard deviation will be 1. Always. If you standardize the data, that means, so I'm going to show you just 1 minute, guys. So that means what we are doing, we're talking about the standard normal. Okay. So when we do standardization, this is your normal distribution. Bear with my drawing. Okay. So suppose this is mu. Okay, and this is your first standard deviation or whatever may be the value, and this is your x-axis and y-axis. Okay, this is your x-axis, this is the y-axis. Initially the mu at this position. When you standardize this data, that means what we follow, every point we minus mu divided by sigma. If we'll do that, this graph will shifted here.
Ashish, like this mu means what is that? Like yesterday I had the network kind of stuff. Because of that I missed the whole class.
We are looking for you, Dinesh, but we couldn't find you, so
Yeah.
we proceed. We proceeded without
Yeah,
you.
like because of that network my whole class was gone. After the class was ended, that network was started to work.
So that means you have like the backbone is missing for you. You are asking what is mu. Okay, that
Yeah.
means what? So
Can you please give a quick recap so that I can,
okay,
don't
no
confuse.
risk. Mu is the mean of the data. Mean. So
Okay.
here 10, 20, 30 we took, right?
Okay, so mean means the
10 plus,
average, as you said, right? As you said before. I mean,
right?
yesterday.
Yeah, 10, 20, 30 by 3. That is your mean. Okay. So initially, if you see this data, the mean is at here. Okay, if this is your x-axis, if this is your y-axis, your mean is here. If you standardize your data, what will happen? The mean will change to here. That means this bell-shaped curve will shift to here. That means what? The mu will be at origin. This is x-axis origin, right?
Yeah,
X and y-axis intersection is the origin. That means this distribution will shift to here. If we'll do a standardization, here your mu will be 0 and standard deviation will be 1.
Okay,
now,
so like if we were spoke about that mean, right? So mean will be on the what do we call that? Like middle of standardization,
origin.
and then if you middle of origin, right?
Yeah. So now the mean will fall. So mean will be 0 always if we will do the standardization. So this is normal distribution. This is called standard normal distribution. This from where we started here, right? Standard normal distribution. But yeah, the worth of a discussion, because this is conceptual thing. Anyone can ask you, what is standardization? What is normalization? So standard normal distribution means if you do a normal distribution and each point in that distribution, if you will perform that standardization formula, the distribution will shifted towards origin. And here, whenever you heard standard normal distribution, you keep one thing in mind. This is a normal distribution where mu equal to 0 and sigma equal to 1 always. That is called standard normal distribution. Okay, this is clear, right? So we started from here, our sampling technique. So that means, I will erase this one. That means to generate a random sample from the standard normal distribution. That means what? We want to take some samples from a standard normal distribution and using inverse transform sampling. So first step, according to inverse sample sampling, generate random variable from a uniform distribution on the interval 0 to 1. What does that mean? That means this x-axis between 0 to 1, you generate any random number from this. We'll do with coding. Okay, this is, we'll perform this in NumPy. You generate random data from a uniform distribution in the range of 0 to 1. Now, so that means what? Suppose this is my x. I am randomly generating some numbers from this interval, which follows a what? Uniform distribution. This is uniform distributions graph, right, guys? So here I generated x1, x2, x3, whatever the number of times I need, I generated the data. We'll do it in NumPy. There's a procedure, you can generate the data. Okay, just explaining the steps to you. Once you generate this, you pass this every point into an inverse of what? CDF. CDF means cumulative distribution function of what? Standard normal distribution. You pass that to a CDF, inverse CDF of standard normal distribution. And one more thing, guys, this notation, if you will refer some research paper or blog, you will find this notation is written everywhere. Now always remember, this notation means, this n means normal distribution, and in the bracket whatever mentioned, that is mu comma sigma. That means what? Mu is 0 and sigma is 1. So if someone will write this way, you try to find out this is a normal distribution with mu 0 and sigma 1. That means a standard normal distribution. If I write this, that means what? Mu is 3 and sigma is 5. Okay, so this notation you need to understand.
So mu and mean were same or different?
Yeah, mean and mu, Dinesh, that's same.
Okay, fine.
And I can observe you caught some cold also. That is also I can sense from your voice.
yeah, it's
Yeah.
correct.
Right. So okay, no worries. You please go through the previous videos.
Yeah. I'll
See,
surely go through it. Yeah.
This one session we split it to 2 sessions. So many things we covered like conceptually. So I don't, because
Yeah,
this is
yeah.
theoretical. In other
Yeah,
batches,
sure. Like actually, I've decided to go through all the theoretical videos once again, but due to this work and all those, I can't able to do it. But surely I'll start it from today.
Yeah, so go slowly and achieve it. But I know like you guys are working, so very difficult to get the time. But go slowly, but try to complete, because so many things we covered yesterday also.
Sure. I'll go through
we're
it.
going very slow here. And if you
Surely
see,
I'll go through.
And one more thing, this thing we will do in NumPy. Let's do it rather than discussing. Okay. So first of all, if you see here, I'm showing this piece of code to show you the first step. What was the first step? To generate numbers from a uniform distribution. Now, if you see, I am using two libraries. One is NumPy. One is another library called SciPy. Now, SciPy is a beautiful library if you are dealing with statistical interference or the mathematical equation of statistics. The SciPy is also a very good library. NumPy and SciPy is a deadly combination if you are analyzing your data. Okay, so it's not simulating in NumPy. This is also along with NumPy, you are learning how to use SciPy. Okay, and in SciPy you have a module called statistics. That means stats. All this statistical inference they have created one. So what this two library is going to do for us? Whatever we learned here, in terms of mathematics, this equation, this inverse of doing something, this PDF. Now we need not to remember these things. We just understood what is these things. This module will help to generate this equation for us. You need not to write it. That means if you see here, I am just importing normal distribution. If you see here, SkyPy.starts import norm. Norm means what? Normal distribution. That means what? This equation. Now, whatever you need to do with normal distribution, that means this one, this equation. So you are not writing any mathematical terms, sigma, 2 pi and all. This is already there in the library. You are just importing this equation. That's all. And so according to our second step, from this inverse transform sampling, according to our second step, what is the second step? We'll do the inverse of CDF of normal distribution. So that's why what we're doing, we are importing normal distribution, then we will, using this, we'll inverse the CDF of this function. We'll see. Okay, so the first step is what? To generate numbers from what? Random uniform distribution. Now again, if you see, using numpy.random, I have uniform distribution equation also. Now this library will help me to gather data from uniform distribution. If I need to connect, I think. So if you want to know more about this distribution, okay guys, so what I think you know what to do, right? What is the, how this,
Yeah, documentation.
Always make that a practice. If you see a new thing that you don't know, please do this, whether you understand or not, but please do that. Make this a habit. And if you see numpy.random.uniform, there is already a function here. Okay, and here you will find what? The required parameter to be passed. Now here low and high is what? The range between where you want to generate the number. Now here, can you see I have given any range? No, right? If you don't give any range, that means what? By default, 0 and 1 will be the range. Size means what? What is this? So 3 parameters here, low, high, that means the range, then size. What is size? If you don't know what is size, you first go here in documentation. So size can be either an integer or tuple of integer, which is actually optional. That means how many data or in which shape, how many columns, how many rows, 3D data, 2D data, you can generate by giving size. But here we are not using size. Here this is an optional parameter. Low also optional parameter, but high by default, if you don't, the default value is 1. So that's why if I'll run this code again and again, see here is 0.7148. okay, let's run it again. 0.617, right? So the more times you run this code, different number from 0 to 1 will be generated, which will be from a uniform distribution. Okay, so whenever you come to a function, always read this one and the below line. This is very important. This will tell you, this line will tell you what the function is doing actually. Okay, draw samples from a uniform distribution. What do you mean by uniform distribution? In a theoretical, sorry, yeah. The probability of drawing a number between a range, this range, the probability of drawing any number between the range will be same for every number that you are drawing. That's why the probability density curve you can see as a what? A line, right? That means the probability is same for every number that you are drawing. Okay, so this is the first step. Generate the number from a uniform distribution. I hope now you clear about np.random.uniform and how this number is getting generated, right? So what is the second step? After you, this is the mathematics. Okay, if you see, this is the inverse we are doing, and this is a proof that if we'll do this, you will get the required distribution. Okay, so let's do the in. So once you generated this data, you pass this to the inverse of CDF. Now inverse of CDF will be achieved by how? Now using this norm.ppf. Now again,
Ashish,
huh,
sorry to cut you off. Like we have given you and all those. Like below to that, you just given you, right? So like we don't need to give print and all.
like that is like if you give print also, that is same thing will happen.
Okay, okay.
But in Colab, there is a functionality you need not to write the print. But if you are using any PyCharm or VS Code, here you need to write a print. Okay.
Okay.
So to print the U, I just wrote U. That this means print U.
Okay. Okay.
Okay. That so just to show you that what is the U value we are getting. Now, if you see the guys, we are doing the same thing here. We are generating the data. Then whatever data or the points you are generating from the uniform distribution, this is, if you see here, this is the normal distribution I told you, right? Normal distribution dot ppf. This is the inverse of CDF. This function will do the inverse of CDF of normal distribution. And again, if you want to understand more, I'm not going because we'll consume some time here. If you see here, whatever number I am generating from the uniform distribution, that number I am passing inside what? Inverse of CDF of normal distribution. Now this, whatever I'm getting as a result, this X is my sample data. What is our aim? Let me summarize you. Our aim is to take samples from normal distribution, standard normal distribution. And if you want to sample data from standard normal distribution, this is the first step. Once you generated data from uniform distribution, you pass that to the CDF of normal distribution, and this is now your sample data. Now this is one sample data or multiple sample data? This X?
One.
One, right? Because here one we are getting. But we have
Excuse me,
to
sir.
take, yeah.
That inverse means you told that CDF from CDF inverse is we are getting here. The inverse means the negative value or what?
No. Inverse means, okay. So that answer lies in that mathematics actually. So what we mean by inverse of a function? So inverse, so y equal to f of x. Now what is x? F inverse y. So this is a mathematical way of interpreting inverse. Okay, guys. So inverse means what? If you put x into the function and getting y, then if you will put y into the inverse of this function, then you will get x.
Inverse means doing the same thing in a reverse direction, right? Like in a matrix, we'll do like 1, 2, 3, 4, 5 means, then we'll inverse it to the 3, 2, 1 like that.
Correct. So Divya, for you, okay, if y equal to function of x, then x equal to inverse function of y. This is called inverse. So we are doing inverse of CDF function. What will be my CDF function in normal distribution? I will do that function's inverse.
Okay, sir.
Okay, so this is no worries. These are mathematical, so you need not to worry about it. Just understand when you are using a function to do one thing. If we'll do the inverse, then like we can come from front to back, then back to form of front, right? Using the inverse function.
Okay.
Okay, so that's why I'm not explaining this mathematics, or you will like, okay, super confused here.
Okay. Now clear.
Okay. So this is that inverse part will done by this norm.ppf. And now this is not done. This is one sample. Okay. Now tell me, suppose I don't want from a standard normal distribution where mu is equal to mu is equal to 0 and sigma equal to 1. I don't want from here. I want from this type of distribution, not standard normal where mu equal to your 5 and sigma equal to 2. Here I want sample. I don't want to take samples from here. I want to take samples from here, where the mean is not 0, it's 5. Are you getting the difference here? What I'm saying? Making sense, right? Now, what will happen if I want sampling from here? This is what you will do. You define your mean from where you want to take the sample, that is 5, and standard deviation is 2. You define that, and whatever number you are getting, you do like this: x equal to mu plus standard deviation into x. That means this, if we'll do, so suppose here x we got 0.3. Now if I want to, this is my sample, 1 point sample from what? Standard normal distribution. If I want to take this sample from what? This normal distribution, where mu equal to 5 and sigma equal to 2. What I will do, I will pass this value in this equation. What is that? 5 plus standard deviation is 2 into 0.3. Now this number, what the value will get, that will be from what? This distribution. Normal distribution, not from standard. So this is 1 pointer. Now suppose you want to take 1000 samples. What you will do? This is 1 point. For 1 point we did this. If I want 1000 samples, what will do? Question to you guys. For loop, guys. I'll run a for loop 1000 times and do the same thing. That's the benefit of using code, isn't it? Repetitive tasks can be automated. So if I want to perform this task for the 1000 times, what will do? I'll use a for loop.
Yep.
That means 1000x I will generate and perform the same action. Every time a new number will be generated, 1000 times a new number will be generated, and the only difference that I'm going to do, I will create an empty list and store these details. That's all that I'm going to do. Okay, so let's do that. Let's take some so if you see, I'm generating, if you see here, creating data list, empty list, which will be my original sampling data. And here I am also creating another variable called uniform. This is also an empty list. Why I am creating this? So that what I will do, I will plot this data and plot this data. It will show you the data we are drawing from uniform distribution, how that looks like. And after doing all this inverse CDF and all, after we collect the data, how does that looks like? Because our aim is to do what? Draw a sample from normal distribution, either standard normal or only normal. That means if I draw the sample and plot the data, that should looks like a bell-shaped curve, right? So let's prove that. So again, 2 variables to store the details, running a for loop 1000 times. And in each loop, whatever we discussed above, that only I wrote here.
Ashish, in that for loop, you only gave in the underscore, right?
So this can be anything. This underscore can be anything. So usually we give I, right?
Yeah.
Or I in range, right? But there, when we give underscore, that means these are things you need not to use anywhere in your code. This underscore.
Okay. So if I'm not using the I, then the compiler will throw me an error stating like the variable not used like that.
No, that is not like you can use anything, but as a, this can show you that you are a skilled developer.
Okay.
That not like that. I'm just kidding. But yeah, the terminal is like, okay, so this parameter is not going to use inside your code. So when we say I or for element in range, so that means what? This thing we're going to use somewhere.
Okay, so through that element, I'm going to achieve something. If I'm not going to do anything with it,
like
then I don't need to.
If element equal to some condition,
Totally.
right?
Okay.
Then print this. So that we are not going to do here. This element variable is not we are going to use. So instead of quick interpretation, I give underscore. That's all.
Okay.
So this means what? Just run this loop 1000 times and perform this action every time you run the loop. What action? You generate one number from uniform distribution. You store that in that list. See, this part uniform dot append we are doing just to verify our uniform distribution data. Okay, this is not the steps, okay, just for us. Now, once you generated the data from uniform distribution, if you see upward, what we do next? We have to pass this to CDF of normal distribution. Okay, so here we are passing this U to CDF of normal distribution. Here we are mentioning we want standard normal distribution. Okay, and once you transform the data inside inverse of CDF, you store that data.append in this list. Making sense? Any query to understand this one? So let's run it. Let's store our data. Now let's try to plot it. Okay, first let's try to plot the uniform distribution that this is the first step. So how does the data looks like from the first step? If you see, let me first explain the code to you. So whenever you want to see the distribution of your data, you can use this function from matplotlib. Matplotlib is to do what? Are you aware about matplotlib, right? No, right?
No.
Yes.
No.
So matplotlib, so see, this few libraries you have to keep in your mind forever, like this numpy, pandas, okay, scipy. These are mathematical related libraries. Few libraries are you need to keep in mind for visualization purpose every time.
So, Ashish, sorry to cut you off. Like you said, SkyPy, right? So SkyPy will like what kind of things that will have?
Statistics, mathematical operation, statistical operation related to everything. Math, some equation you are going to write, some calculation you need to do. So there they have predefined function. Like suppose you want to calculate the standard deviation of the data. How we did for a small example that took us 2 to 3 minutes. Consider you have 100 numbers of data. What we'll do? So using those libraries, we'll see that. Okay, we'll see below that there is specific function that numpy dot standard deviation or statistical scipy dot standard deviation. If you call that function and pass your data, it will automatically calculate the standard deviation for you. Okay, but that is what? Mathematical operation related libraries. What is matplotlib? This is visualization purpose.
Like preprint.
Right, correct. Now preprint is also like kind of visualization, but here is the graphical.
Get it.
Graphical. Matplotlib, C1, Plotly. These three libraries are super useful to plot the graphs that we are going to see also in the upcoming sessions. If you see these things, what I just told you here in this session 19, module 10, okay, box plot, data visualization, pie chart, donut chart, we are going to use these libraries, matplotlib, C1, Plotly, to plot this. Okay, we'll come to that part. This is not done yet. So here matplotlib is to show the graph, and in the matplotlib library there is a function called hist. Hist means histogram. The histogram is nothing but that PDF curve. Okay, so that means some PDF curve, right? Like the normal distribution is Bell-Sav, that exponential distribution is that decaying graph. If you want to see how your data structure or the distribution looks like, you use this matplotlib.histogram function and pass your data inside that. And here this means plots figure and the size. If you will change it to 4 and 4, what will happen? The size of your figure will change. Okay, see, small one we got. So size, other things are there. Okay, once you are familiar with the visualization part, you will get to know. But here, if you see, and the last I'm calling a function called plot.show. That means to show this plot. So now what is this? This is my distribution graph where we are seeing like this, right? I'll sort of see here. How does this uniform distribution looks like? Something like this. where every distribution is in equal probability? Is it, can you see this is kind of similar to that, although not like we have some data here, but at this area, if you will consider this part, every point is at same probability or score here. This is some, and I'll show you what is our aim, that the data we are collecting, right, the data we are taking samples, that should be a normal distribution. So we collected the data, right, sampling technique using what, inverse, what is the technique name, guys?
CDF, inverse of CDF.
Inverse of CDF is the second step of this technique. This technique is called what? We have 4 techniques to do the sampling. Okay, I'll recap you. Okay, 4 techniques to sample the data from a required distribution: inverse transform sampling, rejection sampling. Okay, and in the inverse transform sampling, we are seeing 2 steps. First step is to generate numbers from uniform distribution, then pass it to the CDF of normal distribution. Okay, so these 2 steps is the part of inverse transform sampling. Okay, so here using inverse transform sampling, we capture the data in here in this variable, right? Now let's plot that one, that histogram. Again, same thing I did. Okay, and in the hist function I'm passing data. Now let's see how that looks like. Now can you see?
So that figures, like you have mentioned figure, right? That is to describe the size of the figure that we want to see, right?
Yeah. So
Here we have only data. Above we have the inverse of CDF, right?
correct. Now if you see, does this looks like something similar to you?
Inverse, normal
Distribution, right? So that means we successfully took the sample. Now this data variable is my sample. Okay, let me clear this one. This data variable is my sample now, which is following a normal distribution that we just verified. And if you see, the mean is here. Mean means what? The mean value. The mean value of this bell-shaped curve is 0, and the standard deviation also 1. We'll calculate this also. But this is a visual verification that whatever data we sampled, that is looking like a normal distribution now. Now, if someone will tell you that give me some numbers from standard normal distribution or normal distribution with mu1 standard deviation, can you achieve that now?
Yes,
By
sir,
following
and one more thing, excuse me, and we told me that there are 4 techniques, right? We are seeing that one technique, first technique. Other 3 is there. What is the difference between those techniques?
This is a question to you. Okay, you try to find out, because this is going to take, if you will try to understand this mathematical and the difference, no, it will take another 1 hour to understand. Okay, let not we discuss right now. You try, and here also I'm not going to explain everything. This is just to inform you. Okay, like out of scope of this session.
Okay, that's okay. But I'm asking whether we are going to work with the project one, we will do that inverse transfer from only the inverse transfer sampling or other techniques also.
Other techniques also you can learn and you can try to implement. Okay, this also. Okay. But here, just for your information, I have put it this. Okay, that means and one sampling is enough, guys. That's the aim of your experiment is to do what? Take samples from a known distribution. That's right. But there is a different way to achieve that. Now, which way to use?
One is enough, it's okay. Okay.
No, one is enough. One will be enough. But yeah, different kind of samples techniques are there, just for your more knowledge.
Ashish. The same code you have given, right? So I'm just trying to is this will work on Jupyter or not? But actually it was not working for me.
Okay, what you are doing?
Yeah, I was just
write this one.
Wait a minute. Import numpy as uniform. Yeah, this is the code I'm using, right? Yeah, this is the code that I'm using, but I'm getting an error.
Show me.
Wait a minute. Wait a minute. Is this the one? Yes. On my way. Screen share. Yeah. Hope you, yeah.
So you have to import another library called norm, right? There. Not only numpy as np, you have to import the norm library.
That's SkyPy or num library.
So this one, you stop sharing, I'll tell you.
Yeah.
We'll do that. Let
Sure.
me share. You have
Done.
to import this library. Along with that, import, because already have imported above, that's why it is not showing me error. This one.
Okay, that's SkyPy.norm. Okay, I get it.
From skypy.stars, import norm. That you need to write in your code, and that way it's going to work. So guys, let's prove this. So not prove this, let's see what is the mean of my data. Okay, so you can do this using statistics library and numpy library, both. Now if you
So
see,
just a question, so like above, can you please scroll a bit? The figure dot size, like can you please explain it again?
this one, right? This figure.
Yeah, in the code, like what you have written, the figure function.
Oh, okay. Here, this one.
Yes, sir.
Okay. So first of all, I'll summarize this. What we did, we kept this data in a list, empty list, data and uniform. Okay, and we are plotting uniform. We saw this is uniform distribution, and we are trying to plot this data to show this is normal distribution. So we come here, we use matplotlib library, and here I am calling the histogram function and passing that list of data that we collected. That's all. So if
and
you
the
figure size is 8 cross 8. Okay, if you make it 5 cross, any changes that you want, like this is your your feasibility, 5, 7 or anything, like means what is the length and height of the figure that you want to.
Okay.
So and this figure name is histogram, right?
Yeah, so let's try to let's her to finish first, Dinesh. Yeah, so what you are saying?
This is not something related to the x-axis or y-axis coordinates. It is just the size of the graph that we want.
Correct. And that also you can do x-axis coordinates, the units, those also you can change. Okay, but you have to explore the documentation for that.
Okay, yeah.
So this is just to let me make some smaller figure. So this means so 5 means this row, guys. Okay, so you see 5 cross 5. Okay, and you see this is the graph. If I'll make 10, see what is happening. That means what? This horizontal and 5 is the vertical, right? I'll make it, so to verify, I'll make it 1, it will be very small. The vertical height will be very small. Okay, you got it?
Yeah,
this is what the size means. Okay, so this means 5 cross 5. Let's call 5 cross 5. So this is my data. Now, so this data variable is now my result, which contains in uniform distribution. Now, how to verify the mean of this uniform distribution? Again, in using code, you have to either you can import statistics or you can import numpy. Both will work for you. And both the libraries is having a function called mean and standard deviation, like this. See, guys, here, if you see, tell me what is the length of my data? Anyone? What should be my length of the data that we captured?
1000. Input, right? Length of 1000.
Right. So whoever, 1000 is, that means what? Because what we did, guys, we wrote a for loop 1000 times, isn't it? That means 1000 data points we collected here. That's why the length of my data should be 1000. Now, if you see, by doing manual calculation, this is not possible because 1000 numbers are there. So you just pass this data to this function, statistics.mean or numpy.mean. Anything will be fine. That will give you what? The mean value. That is, this is the mu. Okay, and this is the sigma, standard deviation. And for both of them, we have some predefined function in this module called statistics.mean or statistics.stdev. And we are just passing this data inside that function. Now, I'm not going to see the normalized data here. This is not normalized data. This should be standardized data.
Sir,
Yeah.
if we don't specify any figure size or anything, means it will take a default size or
Default size, default size. If we don't, I think it should be default size. Huh. So to know the default size, again, documentation will help you. I think this is 2 cross 2 or 3 cross 3 it is taking. No worries. So coming back to this one, guys. So I am printing it, okay? The mean value and the standard deviation value of my data. Now, can you see what is the mean value and what is the standard deviation value? This is the mu, this is the sigma. Now, if you want to perform where mean is not equal to 0, mean equal to 5 and standard deviation is something else, 2 in this case. I hope you know what to do, right? In this case, we saw, right? Every point you mean plus that number into standard deviation. If you do that, you will achieve with your desired mean and desired standard deviation. Okay, so this is normalization data is not needed. I was showing to some other batches. That's why I did. So the standardization, see guys, how to do the standardization of a data quickly. If you see here, what I am doing, data minus mu divided by sigma. If you remember the standardization formula. So if you have thousands of data points and you want to quickly standardize the data, this is how you can achieve it quickly. So if you write like this, it will take every point, that means 1000 points we have, right? 1000 data points. Each point it will take and it will subtract the mean from that and divide standard deviation. Now let me run this. If you're doing all these things, let's run this and print. Sorry, here this should be standardized. Okay. Any question to understand this one? How to calculate a mean and standard deviation of the data? Very easy in code. And for you guys, I know, like, if you those who wants to more about the mathematics and on and the rejection sampling. Okay, guys, in the rejection sampling, I'm not explaining right now. I have provided you a very good YouTube video to understand the mathematics behind rejection sampling. That is going to take another half an hour to 45 minutes to understand only rejection sampling. Because that's why let's not do that. But instead of that, I have provided you the YouTube video to go through and understand the mathematics, what is happening in rejection sampling. And this is for you guys. Yeah.
Excuse me, before that, mean and standard deviation comes twice.
Just a minute.
About.
My battery is dying. 1 minute, Divya. Let me charge it or we'll lose the session. 1 minute. 2 times standard deviation you are getting, right? That's what your question is. So one standard deviation is the what we got from here. Here. One standard deviation. Sorry, what we are doing here? We are printing the same thing again and again. Is that, guys? Oh, no. Here we are printing the stuff. Okay. Are you getting confused here? Okay, let me try to. So this is my so this is my normal mean and standard deviation after I got my data point. This is understood, this part?
Yes, sir.
Now let's standardize my data. How to standardize my data? This data minus mean divided by sigma. This is the formula for standardization. Now once I
Now got
Yeah.
it. Before that, normal standardized form, this is for standardized normalization form. Yeah, now got it.
Okay. So now if you see, this is more accurate. Now here, if you see, this is not also close to 0. Here it is minus, that is 10 to the power minus 17. That means 10 to the power minus 17 means you are getting, guys. What is 10 to the power minus 17? That means 1 by 1 in 1, you give 17 zeros in the down. Right? So that is too much close to 0. And if you see here, standard deviation is also very close to 1. Here it is 0.999. Here it is 0.993. So even if you want to, standardize your data to make your mean at 0 and standard deviation 1, you can use this concept. That is the point here to show you this. So guys, this is for you. Okay, I'm not going to explain this one. This is for you. You watch this YouTube video and you try to understand what, like I have mentioned step by step that we did here in inverse transform sampling. In rejection sampling also I have mentioned the steps. But it is to you, go through this video, understand the mathematics and follow these steps. In case of any issue, you ask me tomorrow. Is that fine?
Okay, sir.
Just for a quick, work for you. So what we did exactly, we are doing the same here. We are taking the sample, but this is a different way to take the sample, rejection sampling. Now, what is rejection sampling and what is the steps also I have mentioned, the code also I have provided. The only thing is you have to go through this and understand yourself. And in case of any issue, tomorrow we'll discuss. Okay. Now, guys, this is, so we are actually going very like a turtle here, but I don't mind that. Okay, so session 17 is our today's topic. Okay, should be, it is already 10. So here I have uploaded this notes. Okay, guys, you need not to worry. I have uploaded notes. Here one important theorem is coming into picture, which is you are going to use extensively in your work. That is called CLT. CLT is the theorem, and this is a brain twister actually. Okay, guys, you have to be concentrate on my explanation here, or you will get confused. Okay, the central limit theorem, very basic and widely used theorem. And this is also, once you understand this is going to be fun actually. Now first let's understand what is central limit theorem is saying. If I'll read this, you won't understand. Okay, guys, but yeah, be with me. I'll explain this to you. The central limit theorem is a fundamental result in probability theory that states that under certain conditions, the mean of a large number of independent identically distributed random variables. So let's not go to the too much word. This is the X. It should be independent and identical to each other. What is X? That my random variable. In the X axis, what we are plotting. And the mean of a large number of this will be approximately normally distributed. To understand this, if you see here, regardless of the distribution of individual random variable. Okay, so I'll make your life easier here. We'll do one thing. Where is the pen? So what it is saying, and we'll prove it. There is a proof also. People prove this in statistical, mathematical way in research paper. But okay, but we are not that much level, right? So we'll prove in our level using Python coding. We'll prove this theorem. Now first, understand what this theorem is telling you. The theorem is telling you that suppose you have been given some data. That is xi. Okay, here you have been given some data. The distribution is not known to you. Not known to you means the distribution can be anything: normal distribution, exponential distribution, any random distribution, some zigzag kind of plot you will get. So those data you don't know. That is purely unknown. This is what central limit theorem is saying. The data you have with you is unknown to you. You don't know the distribution. Now, what is the next thing a theorem is saying? The next thing is you take samples from this distribution. You take samples from this distribution. Now, when I take samples, what I need to know about that? How many elements I'm going to take? There, what I did, 1,000 samples we took, right? Like we take one sample, but that sample contains 1,000 elements, isn't it? Here you take samples with your, suppose, for example, okay guys, please be with me here. This is a brain twister actually. So that's why you need to learn these things. It will help you to exercise your brain. So here, this is unknown distribution, xi, and from here I will take sample. Suppose S1, first sample. Now S1 I will take with M1. M1 means suppose 20 elements I took from here to make one sample. In our previous example, we are taking 1,000, right? But here we are taking 20. So from here, randomly, I will choose 20 numbers and I will make one sample. That is my sample 1. This is as per central limit theorem. And I have to repeat this d times. That means what? I will keep taking samples, different samples with the same element. So this is not M1, this is M. That means M is equal to 20 here. Making sense? Now I'll repeat this d times. That means what? S2, again I will take another sample with M elements. Again I will take another sample, S3, with M elements.
Sorry to interrupt you. So, but S1, S2, S3, like we only have 20 numbers, right? So in between 20, like we do have a 20 numbers. So the 20 numbers will be clustered, and it won't have it will not be in a ascending order. It will be
No, Dinesh,
okay.
hold on. So this is my xi. Okay.
Okay.
It contains 10k element.
Okay.
Okay. And from this 10k element, I am taking 20 elements and creating one sample.
Okay.
Randomly from this 10k element, I am taking 20 elements and creating one sample.
Okay.
And I am repeating these steps d times. Suppose d is like 10 times. So 10 times means how many samples I am going to create?
10 samples.
That means S10 till S10 I will go.
Yeah.
Now in each sample, you have 20 elements and you repeated the steps to 10 times.
Yeah.
Till
but
this
the samples will be different.
Yeah, the samples will be different. Because you are taking randomly from this 10k, right?
Okay. The problem is, like you said, you have a 20 data, right? So I thought, okay, I only have a xi of 20, I thought.
No. So that's why this is the distribution you have. This is unknown to you. You don't know whether this is uniform, exponential, any other distribution. You don't know that. You are just, so keep in mind, guys, whatever we are discussing here, this belongs to central limit theorem. This is what central limit theorem is saying, not me or anyone. Okay, this is theorem proved also in mathematically. If we'll follow these steps, we'll see what is the result will happen. Then that will be really funny here. Okay, so see here, you took samples. Till now this is clear. Samples, 10 samples I'll take. Now according to central limit theorem, what is the next step that you are doing? You are creating the mean of each sample. So this M and all, don't get confused. Okay, M means what? 20. Let's not keep M here. So mean 1. So every sample's mean you will calculate. How the mean will calculate?
For 10 samples.
Average.
So this is one sample. I call statistics dot mean function and will pass this S1. That will be my mean 1 I'll get. So for every sample, I have a mean, right? Now, what according to central limit theorem, keep this mean in one list. That is called, if you see here, yi here in this example, whatever I'm explaining, I'm written here the same thing. Okay, take m samples from xi. Do this for S1, S2, mean will be, so here x1 bar I am mentioning, here this is mean 1 I am mentioning. Okay, that means for every sample you calculate the mean and you store that in a list. what you need to store? All the means. And if I'm taking 20 elements and repeating this 10 times, that means 10 samples. Tell me how many means I will get?
10.
10 mean.
10. That means what? Mean 1, mean 2, right? Like mean 10 I will get. Now, central limit theorem is saying whatever data you got here, that is yi, that means 10 means, right? If we'll plot these 10 means, that will be exactly similar to a normal distribution. This is what central limit theorem is saying to us. And we are going to prove this also. But before jump to the code, I need you to go rethink again and understand what I'm saying. You calculate the means, store that means in a list or collect somewhere, and you try to plot it. How to plot? plt.histogram. Here what I'll pass? This yi. This yi contains what?
All means values.
All means. Now, whatever result you will get from this, it will be look something like this. See guys, we started from this 10K data point, which distribution is unknown. Unknown means maybe it's normal distribution, may not be it normal distribution. That doesn't matter, according to central limit theorem.
That
That's
can be
what-
anything like standard, like
Right,
whatever.
So, see, first of all, let's not consider a normal distribution. Even it is non-normal distribution, something like this. You have 10K data points, its distribution is something like this.
Okay.
Okay, some random. But if we'll follow the steps that we just now discussed, and if we'll plot the means, it will follow a normal distribution always. And this we are going to prove also. And to
This 20 and the D10, these all based on our requirements, right?
based on our requirements, to make you understand, if we'll use the D, if you have not used this 2010, we'll get confused, right? So that's why I use this small numbers. But yeah, according how many samples you want to take from this 10K, that is your choice, isn't it?
Yeah.
How many times you are going to repeat. So this means this data I am collecting, this is defining by D. If I want 1,000 data at D, I'll make this D equal to 1,000 times. That means what? I'll repeat this test 1,000 times.
I'll get 1,000 mean value.
Right. So this is to you. Okay. What is the element you want to take? But this has also some importance here. Whatever element you are taking. Now this is not done yet. This will follow a normal distribution, but we are not done yet. What?
So we were
again?
taking 20 samples and that, we were taking 10 samples and the 10 samples has a 20 values, right?
10 samples and every sample containing 20 elements from the 10K data point.
Sure.
Now, the terms they are going to use is the y value, which contains all the mean, right? This is called what? Sampling distribution of sampled means. Okay, so if someone will tell you what is sampling distribution of sampled means, I hope now you're able to make them understand.
Yes, sir.
Okay, and according to the theorem, if you don't know your 10K data points distribution or mu or sigma, you don't know this, right? This is unknown to you. But if you'll follow this, yi will be a normal distribution with D elements. And here the mean of this yi will be exactly nearly equal to this xi, that unknown distribution's mu, according to central limit theorem. If you have 10K data points and you don't know the mu and sigma, and you don't want to calculate using 10K data points, you follow these steps, you collect this yi, that means what? Sampling distribution of sampled means. You collect this sampled means, calculate the mean of the data. This will be nearly equal to the whole population data.
That you are saying that yi we have the 10 means. For the 10 means we are creating, again we are calculating the mean. Is that right?
Means of this 10 means, correct.
Okay.
And that will be same as the original population data's mean, Not same, but nearly equal.
Even if it took, even if we take 10, 20, 30, or 1,000, 2,000, it will be nearly
equal. And
okay.
what is the standard deviation of population? That means this 10K data point standard deviation. Now this, how you calculate the mean from this means list? You can calculate the standard deviation from here. Now if we'll multiply, here one small rectification, guys, this is not divided by root over of m, this is multiplication of root over of m. That means whatever standard deviation you will get from here, if you will multiply, suppose this is sigma I, the standard deviation is sigma I, if I'll multiply it root over of m here, that value will be nearly equal to the standard deviation of the population data. Now here what is m, guys? What we
20, we have 20 in that example.
like based on our
The
example,
number of elements. The number of
so
elements.
so correct. So that means what element we took? 20, right?
Yeah.
For one sample, how many elements we took? Suppose 20, right? So
Yeah.
this is that part. So calculate the standard deviation of this means, multiply it with root over of 20, whatever value you will get, that is the standard deviation of the population data. This is what central limit theorem is saying. Okay, and this is what when we started reading that definition, this is what, now if you'll read this, you will get a clear understanding. Okay, fundamental result for theory, under certain conditions, the mean of a large number of independent random variables, that is mean what? The mean, that means the list of that means we are discussing, right, will be approximately normally distributed. If you plot that, it will look something like normal distribution, regardless of the distribution of the individual variable, regardless of the distribution that you have for the 10K variable. Now we are going to prove this. It's not done yet, but did you understand what this means? The logical part, central limit theorem. Any query on here?
So the last part is slightly confusing.
Yeah.
Which
Same
part?
here.
Tell me which part.
The theorem says that below one.
So the mean of what? Mean of xi, mean of yi. What does that xi, yi? You tell me.
Yi is, we have taken the mean from the samples. So
Correct.
out of that, we are calculating the mean.
Right. This one is. What is mean of xi?
Mm,
Mean of xi is the original population data whose distribution you
Okay.
don't know.
Okay, yes.
So see, we have a whole large population data where that mu and sigma we don't know. We only know the mu and sigma of what? This one, samples mean. But we can calculate the original population data's mu and sigma using this. If you have the mean of this one, then that will be nearly equal to the population mean. If you have sigma of this one, that will be sigma into root over of m. This is the population mean. Okay.
Can't we calculate by using the formula that we have in the NumPy library?
Xi, right? Xi you are saying.
Xi is mean.
You will put here, and but yeah, so very good question. But this is a population data. I told you yesterday, right? Population data is very huge. If we will compute this also, you are consuming some computational resources. Suppose 10K data or 10 million data. If we'll try to compute the mean, it will take some time, isn't it? 10 million data you are getting.
Okay, so instead of that, we are taking samples and
proving
that it is equal to that large data.
Right, correct,
Okay,
exactly.
okay. Yeah.
So even if you don't know the distribution also, you can say what is the mean value, what is the standard deviation value.
The standard deviation here we are calculating that sigma into root to the power of m you are writing. We are calculating the standard deviation, the sigma sign. Without knowing the sigma sign, sigma value, how do we multiply with that root of m?
So Deeply, I think I'm not sure it is only to me or to everyone. Your voice is a bit low today, very low actually.
It's so muffled.
Am I audible, sir? Now
yeah, you are audible, but your pitch and sound is a bit low. I'm not sure why, Maybe you are away from the mic or speaking in a loudspeaker, or I'm not sure. So you are asking about this AM, Divya, this root over of AM?
Arjuna said that sigma sign.
Sigma sign.
Sigma.
Here, this
That
one.
sigma into root to the power of m.
So here it is a modification. It is not divided by root over m. Please keep in mind.
Into is okay. I am asking that we are calculating sigma, right? Standard
Sigma,
deviation.
correct.
Standard deviation into root to the power of m. We are putting that formula. Without knowing that sigma, how we can multiply with that root of m? So I'm asking.
Without knowing this sigma, so this sigma is not this population sigma. This sigma is what? This sample that you collected from the means. So from this list, we are identifying. Okay, I think you guys are getting confused. So mu population, sigma population. Okay, this is belongs to this one that we don't know. Here mu mean sample or sigma mean sample. That mean means like a list of means I'm saying here. Okay, this part. Okay, now mu population will be nearly equal to mu mean. That means this means data, and sigma population will be equal to what? Sigma this. Sigma mean into root over of m.
Yeah, okay, sir, okay. I'm just confused.
I got to, because I didn't retain this population and mean, that's why you were getting confused. But now it is clear. This sigma is population. Yeah, okay. Now let's prove this, guys. Okay, in code. This is going to be fun. Now, first of all, this 10K unknown distribution I told you, right? So here we are, that unknown distribution, we are generating the data from a uniform distribution. Just to showcase you that actually, according to central limit theorem, this distribution is not known. Okay, not known to you, but to prove this, we are taking the samples or the data, that 10K unknown distribution from our previous example is from a uniform distribution. That means what? I am creating 10,000 data points from uniform distribution, and I plotted the data also. This is looks something like, so whenever you see some plot like this, you can see what? This is uniform distribution. Are you getting it? So this, knowingly, to prove this, I am generating 10K data points from uniform distribution. This is clear? Okay, let me run this. Is it connecting? Okay, connecting. So this is my, so consider this is my unknown distribution. That means what? This mu population and sigma population we are going to calculate by following the steps that is written in the CLT, central limit theorem. Okay. Now what is the first step, guys, in central limit theorem? What is the first step here? If you, so this we generate, take the samples, right? So this part xi we generated from a uniform distribution, 10K data points. Okay. Now take samples. Okay. How many samples I need to take? Here I have defined samples. So here this there is an empty list called samples. So this empty list I'm creating to do what? To store my samples. That is that S1, S2, and S3. Those samples, not the means, guys. Don't consider these are the means. These are the samples, S1, S2. And here AM I am taking 100. That means what?
100 elements.
From 10,000 elements, I am going to take 100 elements and make samples. And this is my D. That means I am going to repeat this 1,000 times.
1,000 times.
That means how many samples I am going to get? 1,000 samples. Everyone had, we all are in same page. Anyone wants any clarification?
Yeah.
So that means if I'll store my samples in this list, what will be the length of this list?
1,000.
Right, because we are storing 1,000 samples. And each sample contain what? How many elements? 100 elements. Okay, now let's do that. Let's take the samples. How to take the samples? Here there is small bit of conceptual understanding you need to develop here. This is the for loop. I am taking samples 1,000 times, right? This is understandable. Is it making sense? Here,
Yeah,
how
yeah.
to take sample, there is two choices. Okay, if there is a library called random. This random library, random, numpy, statistics, these are very useful libraries to deal with these statistical approaches. There is a function called random.sample. Actually, two functions: random.sample, random.choices. Two functions. Both are their own, consequences. There is a concept called sampling without replacement, sampling with replacement. Can you try to understand what these two terms are? What do we mean by sampling without replacement? Now, suppose you have a data.
Able to change the element.
So, Divya, your voice is too slow today. I'm sorry, I can't hear you, but yeah, I can guess you are saying something. But if you see, what do we mean by sampling without replacement? So, suppose this is my data. From here, I want to take the sample, and I took what 1, 4, and 8 as my first sample. Now, sampling without replacement means this is sample 1. Okay, if I took sample 2, these three numbers should not be repeated. I'm going to take 3 elements from this 10 elements, right? And this is 1, 4, 8 I already chose. Now, if I'll do any other 3 number, that is 7, 9, 2. But these numbers should not be repeated. It cannot be 7, 9, and 8 because 8 has already taken in one sample. This is called, if you don't want your sample data to be repeated in the next sample, this is called sampling without replacement. And if you want the same number, suppose in S3 I got 2, then 5, then 1. Here 1 is getting repeated here also, right? In sample 1 also, in sample 3 also. Now this is called sampling with replacement. That means if you don't want to take the elements you have already taken in one sample, that is called sampling without replacement. If you this is not a problem, repetitive element can be also fine in every sample. That is called sampling with replacement. Did you get this concept?
Yeah, but that won't affect the result, right? With or without replacement, that won't give us any.
We are not talking about the result. That is total different thing. But these two concepts, sampling with replacement, sampling without replacement.
Yeah, that's clear. That's clear.
Understood, right?
Yeah.
So based on your domain demand or your domain requirement, you choose whether your data point you want to be repeated or not. Okay, that's what the concept is here. So suppose we go with sampling without replacement, okay, or sampling with replacement. So if you will go sampling without replacement, you have to use random.sample function. You have to, if you want to go sampling with replacement, you have to choose. Yeah, Divya.
Am I audible now?
Yeah.
And while
Now
learning the theory, while learning the theory, first we have that xi elements, 10k elements or somewhat. That time you told me we don't know about the distribution. It can be any kind of distribution, like the way you told. But here we have used the uniform distribution method.
Correct.
Why do we here we use that?
Uniform. Why we use uniform distribution, right? That's the question. So just to prove you that that xi distribution is anything, but if you follow the step at the last, you will get a normal distribution. Just to prove.
Okay. Actually, I got that doubt only mostly.
No, not a problem. Please keep asking questions like this because this is first time and fundamental thing. Okay, you need not to get confused every time. So that is because just to prove that is different distribution and what we are getting is a different distribution. That's just to prove that. Now here we took the sample, guys. Okay, let's do that. We took the sample. Let me erase these things. And what we are doing after taking the here, guys, what is the arguments we are using in this function? The data. What is this data? where the data come from, that variable? That uniform, guys, right? This one. See, this is the unknown. Just now Divya asked, right, about this one. This is we are taking uniform distribution data. So this is my data which contains 10,000 elements, and from here we are taking the samples. That's why the first parameter is what? Data. And
Okay.
A means what? A means the number of elements, from how many elements you want to take samples from. Like here M is 100, right? That means go to that 10,000 data points and create 100 element sample. And we are repeating this word 1,000 times.
100 element sample, but I'm doing it 1,000 times.
1,000 times.
Okay.
And that means I'm storing all the samples in this list, that empty list, samples.append. Now, obviously, this list length will be 1,000 because 1,000 samples are here inside this list. Let me run that again, 1,000. Now, what is the next step? If you go up, what is the next step? After
Now,
repeating this S1, S2, what is the next
we
step?
should calculate the mean.
Yes, calculate the means of every sample and store that in a list.
Yeah.
And that list is called what? Sampling distribution of
Sampled mean.
Okay, catchy name, right? So
Confusing name. It's
no,
sampling
that's
distribution of sampled mean.
See here, this is my, just now you said sampling distribution sample means, right? That list
Yeah.
I'm creating here, an empty list to
Okay.
store what? All the means. And how to calculate the means of every sample? You iterate over the sample list which contains 1,000 sample, and each sample you use this mean function to calculate the mean value.
Okay.
Did you understand this code?
Yeah, instead of learning the theorem, like applying it in the program is so much easy. Like statistic.
Yeah, that's what. This is fun. So the thing is, like, this is going to be fun actually. So like this, you can prove it. What people are proving in mathematics and all that theory paper, you can prove. Not like 100%, but yeah, certain portion you can prove, right? Now, if this is my sampling distribution of sampled means list, where I'm storing all the. Now tell me, what is the length of this 1,000?
Yeah.
Now 1,000 means what? 1,000 means we have.
Yes.
Now, according to central limit theorem, what it says, if I'll plot this sampling distribution of sample means, it should be what? A normally distributed graph.
From the matplot, what is that matplot? IP, yeah, matplotlib, right? So from the matplotlib, you are particularly accessing the pyplot, right?
Correct.
Okay, done.
And I'm giving a nickname to use because I can't write every time this long word.
Yeah.
PLT. Okay.
Yeah, like
and
we do for pandas and all those.
Right. PLT.histogram. Again, to know the distribution of your data, PLT.hist. And here I'm passing that means which contains 1,000 means. Now, this is one type of proof here. You can see what? This is following a normal distribution.
Yeah.
Usually our data was looking something like this. Here we took the samples. Now the more samples you are going to take, the more it will close to a normal distribution. That is also one part. That means here we are taking 1,000 points. If you take like 5,000 samples, then it will be more towards more bell-shaped curve.
Okay.
And what else part we saw in the central limit theorem? This part.
And then the theorem says.
Now xi means what? My uniform distribution data. Do you guys agree? Xi means this my 10,000 uniform distribution data. And yi means this means list. Now, according to central limit theorem, if I'll calculate the mean of this data, in real life scenario, to calculate the mean will be not feasible, right? Because the data set is large or we don't know. But here to prove this, we have the data now. We can calculate the I think this are asking these questions. We can calculate the mean now from this data.
Yeah, as is like, however, like this, the theorem says part were there, right? Like mean is nearly equal to, as you said, like that mean of xi, like the pop, like the what is that we say? Oh God, I forgot that. Like that
Nearly equal to
distribution. Yeah, that is nearly equal to the mean,
mean
which
of
we calculated with the sample
right. Sampling
element.
distribution
Yeah,
of sampled means.
yeah, like below to that, that standard deviation of xi, that thing was there, right? You're going to explain it once again under this.
So we are going to see this.
Okay.
This holds true. We have
Okay.
the point is we have the required data now, right? We have the xi now. What is my xi? That's what I'm asking. What is my xi here in our code?
Yeah,
Data.
xi is
Data. This one,
10,000. Yeah.
right? What is
Yeah.
yi?
The 1,000.
This one means.
Yeah.
So two variables. Xi is data variable. Yi means the means variable. That you understood?
Yeah.
Now whatever,
Totally.
whatever the center limit theorem is saying, let's start prove that. So first of all, let's calculate the mean of the. So this is my population data. That is data variable.
Yeah, the
I calculate the
10,000,
mean.
right?
Xi. This is xi.
Okay.
So we are going to prove what is xi and what is yi, whether that is same or not, because center limit theorem that tells that, right? Now standard deviation also you can calculate from the data. Now you have mean data. There also you can calculate the mean and standard deviation. Now here, see, forget about this code, okay? You see the result here. Population mean and the sample mean. Can you see these are equal, nearly equal?
True.
Population standard deviation and standard deviation of the means. Can you see this is nearly equal?
Yeah.
True. Now, if you see, according to this, the mean will be nearly equal. That is not a problem, right? What is the standard deviation? You have to multiply square root of m. Here, m we taken as what? 100, isn't it?
Yeah.
So the standard deviation of the sampled means into square root of the element will be nearly equal to the population standard deviation, which is also holds true here.
Ashish, I'm sorry, like I suddenly forgot what is standard deviation.
Standard deviation you forgot.
Yeah, like what's happening to me? God.
No, that is fine. Standard deviation, it's a different topic. Let's forget that. What is standard deviation? But let's find, like, if you want to calculate the standard deviation, this is how you will calculate.
Sure. Okay.
You keep this in mind.
Sure. Okay.
So that means this one we prove that even if you don't know this population mean and population standard deviation, you don't know this, okay? But for the proof concept, we calculated this. This one you don't know. But using the sample.
Excuse me, sir. For the total population, we can't able to do the mean and standard deviation and other things. For that, we have used the sampling techniques. Actually, that we are getting samples from that whole data, and we are calculating the mean and the standard deviation. That is instead of using the population and calculating the mean and the standard deviation, we are using this technique and we have calculated these mean and the population. This is the purpose of this.
Correct. Exactly. You got the right thing here. So you need not to calculate the population data like this. Even if you have the sample, if you follow the center limit theorem, you can also say the population mean will be nearly equal to this value. The population standard deviation is nearly equal to this value.
Ashish, correct me if my understanding was wrong. Like if it is 1,000, that is fine. Like if I'm having more number of like 20 million, 30 million, like I'm not sure that much of amount like I can deal with if I'm going. So on that time, my system will get collapsed if I'm trying to calculate the population mean and population standard deviation. Instead of that, like I can go with this and I'll have an idea. Okay, this is more or equal to this, like that, right?
Correct. Exactly.
Oh God, I'm a genius.
So no guys, so I am really happy that you are getting, because this central limit theorem, when I used to study this, I studied for 2 days. I didn't get, but that's why we are
Okay.
here, right? That's why you have me here, so that you can save
Okay.
some of your time to, like, what I know I can pass to you, so that you can pick from there. It is not end, but some,
Sure.
kind of lifting technique, you can say.
Okay.
So you need not to now spend 2 days to understand CLT. You have me, and I made you understand. That's my like, satisfaction here. Okay, I'm glad that you got it. And I'm like also waiting for you guys to implement in your real life work. Okay, if you're planning to, or if you are also working, right? So try to implement these things. Try to play the things that you are learning, so that then only you will get the path. Okay, because this you need to apply somewhere, then only it will make sense. Okay, now if this is clear, there is another concept called degree of freedom, guys. Okay, now why we are discussing of degree of freedom? Because this concept we are going to use in our, so there is another type of distribution like normal exponential, that is called chi-square distribution. Okay, chi-square. Okay, I think you have here chi-square distribution, CLT and its proof, chi-square distribution and its properties. Okay, that's what. But to understand chi-square distribution, you have to understand a concept called degree of freedom. Now I'm not going to tell you the book written explanation here. Just in layman term, understand what is the degree of freedom. Suppose you have a data variable x which contains, just 1 minute. So suppose you have a variable called 10, 20, 30, 40. Okay, here what is the degree of freedom? Length of x minus 1, that's all. Now why it is this, how it is this, we can explore later. But to understand quickly what is the degree of freedom, if I ask you what is the degree of freedom of this list, then you can say what? Length of this minus 1. This is my degree of freedom. Okay, now let me read it for you, so that you can now understand. But this is the gist of this writing. Okay, okay. Let me show you. So the degree of freedom, in statistics refer to the number of values in the data set that are free to vary or unconstrained in determining a statistic. I'll come to what is this free to vary. Okay, in other words, it is the number of values that can that can be adjusted in a sample to calculate a particular statistic. For example, when calculating sample mean, the degree of freedom is equal to the sample size minus 1. Because once the mean is calculated, the other values are determined. So that's why we are subtracting 1 from here. Now, if you remember our sample and population variance formula, there we are dividing with n with population, n minus 1 with sample, right? So that is the concept of degree of freedom. Because if we'll collect the sample, we have length minus 1 freedom to vary the data. For example, if you have 10 people's height, okay, and you want to see how the variation looks like. Now to see the variation, how the variation looks like, you have to find the midpoint or the mean value. From the mean value, you will see how the data is deviated from the first standard deviation, second standard deviation. Now, when we calculate the mean, actually we are referring a mean point. So here, if you see what it is telling me, suppose I have 10 data here and I calculated the mean. So one data I occupied to take the reference from here, how the data is deviated. Now you have 10, usually you have 10, right? 1 to 10, right? Here it is 1 to 10. You occupied one position to refer. Now, how many positions you are free to move from the 9 position? Sorry, from the whole position. One position you already occupied, that is mu. From here
9
you
positions.
are going from there, from here. So the freedom of going there and here is length x minus 1. So that's why degree of freedom is minus 1. This is one type of explanation. In statistics, people do lots of discussion and all regarding this. I'm not going to that part because that is not our area. We are just simple people. We understood length of x minus 1 is degree of freedom. That's all. Okay, so once you understood degree of freedom, now we will jump to the chi-square distribution. Okay, let me erase it.
So like with the sample mean only, this degree of freedom will be calculated, right?
No. Whenever I say degree of freedom, you
Uh-huh.
consider the random variable x.
Okay, that 10,000.
10,000. And now,
Okay.
what is the degree of freedom of that? If that is a sample, 10,000
like
minus
999. Yeah.
Right. So that is the degree of freedom. So whenever I say degree of freedom of something, you understand in this way. It will be
Okay.
easier for you to grasp. Okay, if we go
Okay.
this definition once.
9,999.
Correct. And we have, so this is not a small thing, guys. This is a very big thing in statistics. Using this degree of freedom, we are going to see, okay. And the next session also, I'm not sure whether we'll be able to cover today. You are going to see this is very useful degree of freedom. Without degree of freedom, you won't be calculate any statistical value. Okay, so let's understand chi-square distribution and its properties. Similar kind of thing like we saw normal distribution, exponential distribution, like that chi-squared. But here chi-square is not a specific distribution. It depends on x, f of x. If you remember, f of x, x means the variable, and k is the degree of freedom. That means the data size along with the variable, the size of the data also playing a important role here. That means if you take 10 samples and if you take 100 samples, chi-square distribution will be different for both of them. Try to dive.
Ashish, can you please, come
So
again?
so the not problem, guys. Okay, see, these things are purely mathematics and statistics. Okay, semesters courses are doing people on this, and we are studying this in one session. That makes sense.
Okay.
You are not understanding, that is a good thing, because it's a vast topic and we are trying to cover in a small. So to know more of this, okay, mathematics behind it, I have given this page if you can refer. But what I just said, every distribution has their PDF, right? PDF function you can write mathematically. This is the mathematical form of chi-square distribution. I'll come to the individual terminology here. But if you recollect the normal distribution, how many variables were there? We're defining the equation x and mu and sigma.
Yeah.
Right. Here two variables x and k. They are x mu sigma to describe normal distribution. Here to describe chi-square distribution, you have x and k. Now x making sense to you, right? X, what is x? The random variable. What is k? The degree of freedom. Now tell me what is x and how to find the k. You give the example rather than I give. I have already given you so much example. You tell me what is x? What do you mean by x here?
10,000.
10 elements easily we can get.
Yeah. Suppose this is my xi, right?
Yeah.
This contains 10k elements. Now is this x here I'm referring? No. X means individual point in this data. That means x1, x2, x3, x10k, right? Because this data is containing this, right? So this function is taking these values as x. That means x is a variable which can take x1 or x2 or x3 like this. Making sense?
Elements, all the elements in the data.
Huh. That means this is my x. That means this x can be this x can take either anything, x1, x2, x3. So I told you, right, yesterday, y equal to f of x. How we are plotting the graph? How we are plotting the graph? We are putting one x and we are calculating y, and we are getting a point x and y. This is x1, y1. another point x2 y2, another point x3 y3.
Okay.
When we join that, we got that distribution, right? Okay, so this x1 y1 is what? This, when you put x1 here in this equation, that means in place of x, you are going to put what? X1 value. And whatever value you will get as y. Now you plot that 1 point. Again, you take x2. So this is the combination of all this data.
So that x is the any like in the 10,000 variables, it can be anything. Like it can be an
Correct.
8,000 element of the xi or like that, right?
Correct. So x is a variable. Variable means what? What do we mean by variable?
And
Which will
vessel,
vary? Which will vary?
yeah.
Here it will vary from what? X1 to x10k. Any value it can take. And we are defining the relationship between them using this mathematical form. What is the relationship between them? Y equal to f of x. Now here, what is my f? This equation. Now here, one catch is here. We are not only taking only x. Here, along with x, that is another input parameter that is called what? Degree of freedom. Now, what is the degree of freedom of this list? 999.
999, yeah.
10k minus 1.
Yeah.
So when I construct this equation using this data, I will write what? F, then this data name is xi with 10k minus 1. Then there is the equation. And here 10k minus 1, that is degree of freedom, we are passing where? If you see here, this is xk to the power 2 minus 1 e to the power minus x by 2 divided by 2k to the power 2. This is, I'll tell you what is this. This is a mathematical function. We need not to worry about this one. Just understand in this equation what we have. This x variable we have and the degree of freedom we have. Now if I change this xi to 9k. Now what is the k? K will be changed.
Yeah.
So the whole output of this calculation will be changed because k value is changed. So
Yeah.
that means chi-square distribution depends on x and the degree of freedom of the data. And one of its properties is saying, if you increase the degree of freedom, what does that mean?
Increasing the k value. Yeah.
Length of the data. If you will increase the degree of freedom means what? Increase the length of the data. If you will increase the length of the data at a certain point, the distribution, if you will plot, suppose at k equal to 1000, k means degree of freedom is 1000 and degree of freedom at 50. The curve looks like something at 50, but at k equal to 1000, the curve will be a normally distributed curve. This is the properties of chi-square distribution. With increasing number of degree of freedom, your distribution will be similar to a normal distributed data. That means a bell-shaped curve you will get. With what? Increasing number of degree of freedom. Getting right? So let's see that. Let's see. So this is mathematical way. I told you yesterday, right? Two ways. One is mathematical way, one is visual way. So let's see the visual way here.
Excuse me, sir, just one doubt. That here we are giving that f of x comma k, that x will be the element of, if we have 10 elements, simple example, that will be any number between 1 and 10, right? We are
Correct.
doing that for a single element. If we took 2 as x means, we are calculating that formula using 2 and k, the midpoint of the 10.
Right.
Mean we are calculating and we use this here. This will be working for only one element, or do we have to do for all the 10 elements?
No, you need not to do anything. That is the, just to make you understand, I gave that example. This is the relationship equation. between all the elements. You need not to put any value, just to make you understand how this related to your data. This is a relationship. This is the mathematical relationship. When I say y equal to f of x, this is the f, this part.
Okay, okay.
And
For the understanding, you are told,
correct,
right?
correct.
Okay, okay.
So again, like you just need to understand. So when I say a curve, how the curve is generated and all, for that purpose, I give you the example. This is the relationship, or this is the function of what? Chi-square distribution. This is the what? This is the PDF of chi-square distribution. Okay, we'll don't worry guys, because we have not finished yet. We need to see something here, and we'll prove the properties. Now where I have written, okay, x is the random variable representing the chi-square distributed variable. K is the sorry, k is the number of degrees of freedom which determine the shape of distribution. The higher the degrees of freedom, the more the distribution resembles a normal distribution. I told you, right? If you increase the k here, if I increase the k means what? I am increasing the data set size. If we increase the data set size and try to plot this, you will get a bell-shaped curve. We'll see that, okay? And what is this gamma? Gamma k by 2, it is a mathematical function called gamma function that is used to calculate the area under the curve of the distribution. I'm not going to this concept, what is the area under the curve. You try to understand, this is a mathematical function in terms of degree of function, which will calculate the area of the curve. Area of the curve means what? Like if you, once you plot some data, something, suppose I plot this graph, the area under curve means what? This area. Okay, so this is related to this kind of concept. Let's not go to that, because anyway, we are not going to use this separately. We have what? We have our Python library, right? So everything that we are seeing here, just one piece of code I will write, and there is a library called chi-square, chi2. Okay, this all. You just import chi2. That's all you need to write. Import chi2, and you will import this whole thing. The only point is you need to understand what is happening behind this library. You can tell now this is the mathematical equation. Okay, here k is the degree of freedom. Like that, you have to explain. Now, what is the first property? The mean of distribution is equal to the number of degrees of freedom. That means if you have your distribution is following chi-square distribution, what is the mean of that distribution? Degree of freedom, equal to degree of freedom. So I told you yesterday, right? We are learning this known distribution to utilize this in our real life. So somehow you got to know your data that is given to you is following a chi-square distribution. So immediately you can say, what is the mean value? Length minus 1.
Length minus 1.
So that's why this is useful to know its distribution and the properties, so that you can utilize this concept in your real life. What is the standard deviation or variance? So sigma square means what? Variance. Variance will be 2 into degree of freedom. And the distribution will be positively skewed. Guys, here, what is the time? Oh, it's 11, guys. Can I take 2 more minutes? Okay, 2 more minutes, please. When I say positively skewed, just a minute, here. Skewed means like this. Suppose this is my normal distribution, and I have data towards right also. It is not finished. So this kind of distribution is called skewed distribution. And basically this is particularly called right skewed. So now if your distribution is more and not, if it is more in the lower region part of your graph, that means it's skewed. What is the left skewed? How does it look like? Left skewed. This is left skewed data. Okay, so why I'm telling this thing, because you are going to encounter these terms, okay, in real life. Someone will say like, you have a right skewed normal distributed data. If you don't know what is right skewed, what you will going to understand from there? So when I say right skewed normally distributed data, that means what? The data is more distributed towards the lower region, towards right. So this property is saying the distribution is positively skewed. That means whatever graph you are going to get, you are going to get some more data towards the lower region.
So if it is right side skewed, it will be positive. If it is to the left side, it will be negative, right?
No, not like that. Positively skewed means towards this also, towards that this also, left and right also.
Okay.
Okay, hold on, like getting late, right? So just let me finish the properties, then we can wind up, right? Just a minute. So what is the next property it is saying? The distribution is often used to test hypothesis about variance of population. For example, if you have a sample of data, you want to test whether this is called goodness of fish test. Okay, we have example for this one. So suppose you have one data with you, unknown, you don't know what is the distribution, whether normal, whether exponential, whether you can use chi-square technique, chi-square distribution technique. Suppose you are thinking this may be following a normal distribution, but you are not sure. You can do a test using chi-square test, that is called goodness of fit test, to confirm whether your data is actually following normal distribution or not. Okay, but here I am not, guys, shall I explain the code to you? Because it will take another 10 to 15 minutes. Just to show you, let me show you. Let's not explain the code today. This is how I plotted the chi-square distribution with different degree of freedom, with same x, but different degree of freedom. And if you see, with increasing number of degree of freedom, that means that degree of freedom is equal to 100. The distribution is looking something like what? A bell-shaped curve.
Excuse me, sir. Just one note, we are increasing the degree of freedom. The degree of freedom is n minus 1. This is the degree of freedom.
Correct.
The increasing the degree of freedom is we are every time we are increasing the data value and then we are calculating the degree of freedom.
Exactly.
Right?
Exactly. Very good.
And what is the purpose of this?
The purpose is, we'll see its uses, okay, once, because it's not finished yet. So we'll see that one. I told you goodness of fish test you can do using a chi-square distribution, goodness of fish. That means whether your data is following a known distribution or not, if you want to test that. Okay, if you want to test whether your data is following a normal distribution or not, you can use chi-square distributions good fish test, which we are going to see not today but tomorrow.
What is a good fist?
Sorry, goodness of fit test. Okay, guys, okay. Goodness of fit test. Okay, we'll see this. Let's not do this today because I can see people started leaving, and also it will be hectic, right, guys? Today also we covered, but we are going slow. But I hope you are getting it right.
Yeah.
So how we plot this data with a different degree of freedoms, I will let you know tomorrow. Is that fine? Or shall I explain it today and tomorrow again we'll discuss?
We will go on tomorrow.
Okay. No worries. That's all. I was just taking a chance whether you guys will okay, then I'll explain. Because see, I think till this part we covered bit point and interval estimators and MLE. Okay, these two concepts and hypothesis testing. So as soon as we complete this one, we'll move to this visualization. Okay, because these all are conceptual things, although theoretical but conceptual. Hypothesis testing will be, again, it will be like, I know you guys will ask me so many questions. I'm totally happy with that.
Okay,
so let's see tomorrow. Okay guys, let's see. So we'll discuss how this code I defined in this one, and then after we have what point and interval estimators. So how to calculate the critical value and all. So there is some statistical approach you need to follow. Do you guys know what is a log table means? Log table?
I heard of log, but I skipped it
So
in
Yes,
12th
sir.
everyone,
standard.
All them have used that.
so you guys use
Yeah, we
log
used to give a log book and we have to find the values from that book.
correct. If you
Yeah, we
see
used to have like that log and all those, but I skipped it in 12th. But
I
now I'm
totally
suffering.
forgot.
if you recollect in the exams, you have been given that extra paper which contains log table, right? So
Yes, sir.
those similar kind of thing we are going to use here. That is called a T table and Z table. Tomorrow we'll discuss extensively. So these are statistical concept, okay? And people used to read it in semesters, and we are reading it in one session. But that is fine. We are taking the gist only, so that whatever required for our DS job, we'll understand that. Okay. So tomorrow we are going to see what is a G table, T table, and where to how to use G table and T table too. So these are actually, typical statistical approach, advanced statistical approach you are learning to analyze your data. This is not so simple thing you are learning. Advanced statistical approach you are learning to analyze your data, and this data is not going to not going to be wrong if you are not calculating in the wrong way. But if you calculate everything in the right way, this estimation is going to help you in your work environment. What is the mean value? Suppose that example I told you, right? That product age group, how to find. If you have that data, you can play with the data and create meaningful confidence interval, or calculate standard deviation and mean of the population data, like that. And did you guys get your project mail, or still
No,
waiting?
still
Yeah, better you wait, because once you get that, you start banging your head. So better. I'm not sure why you are not getting, because we have already completed till module 9 now. We're almost finishing module 9,
yeah.
and that should be given to you after module 7.
Okay.
Okay,
And
so
Ashish, this may sound silly, but I'm asking, like we were seeing all these theoretical stuffs and all those, right? CLT, CDF, geometrical distribution, binarily, and we were seeing all this, right? So these all will help us to understand our data more and more, right? Like, because
right, correct.
as a human being, we can't go and see in each and every data, like, okay, how much data I have, like how much space it may contain, or how much time it may take to process, or what kind of data I have,
Correct,
to find all
correct,
those, these things will work, right?
correct. And
And
also,
uh,
yeah, go on, go on.
yeah, you go on, you go on.
So, and also it is also helping you to do your brain exercise, stretching in your brain in all possible angles. Take, practicing the patience things also by sitting and learning this theoretical concept.
No, like,
Learning.
I'm asking that, if I'm going in a corporate, I'm asking, like, for example, I'm like, we'll take an example of you, like you're working now, right? So uh, with all this, like, I'm asking, with all these things, like, I do know that, like, we won't use all these things at the same time, like we won't use CLT, or we won't use CDF, geometrical, binomially, or what is that?
Hmm. Hmm.
Oh
Yeah,
God,
correct, correct.
Bernoulli, or whatever, like,
Bernoulli.
yeah, Bernoulli, yeah, that's what. So
Right.
Bernoulli, we won't use all those at once, because we'll have some plans, or else we'll have some project documents and all those. So we'll go through that, and we'll work accordingly. So on that times, I'm asking that, with this, what kind of clarification we'll have, or how these things will work in that real
So
time stuff.
first of all, you need not to join a corporate work or any kind of other environment. You
Mm-hmm.
have working somewhere right now, and you have your data.
Mm-hmm.
You have numerical data with you. You started playing with the data with these concepts. Now then you will get the benefit. So whatever you are saying, no,
Mm-hmm.
which part to implement and all, you started implementing in your work area. You have numerical data
Yes.
set with you.
No,
Experience, yeah.
actually, I'm totally from a client relation kind of stuff. So I'm kind of guy, like, it's related to business analyst, but not business analyst like that. Like, I'm in a management side, but
Okay. Okay.
It's
I know,
totally
I
different.
got it. But see, if you have numerical data, you can calculate the mean and standard deviation. That privilege you have, right, from the clients. Or if you
Sir,
want to plot the data.
can I explain our office scenario? How can I implement this in that environment?
Sure. Sure.
Actually, I used to work for a DSA company, like bank. We get calls from banks for loans, right, sir? I
Okay.
used to
Okay.
work as a HR for that company, and
Okay.
I used to train some whoever new joinees. Their job
Mm-hmm.
is to call the numbers given to them. Like you all might know about
Yeah,
BPOs,
yeah,
right?
yeah, yeah, yeah.
Right. Right.
We do.
Yeah.
Yeah, similar type of stuff going on. How
Mm-hmm.
can we apply this data science there? Here I
Mm-hmm.
joined in intention that if we have a data regarding the numbers of customers, targeted customers, if we apply some data science tools or some
Mm-hmm.
statistical approach to filter them, so that we can filter 10 out of 100 customers, so that we can reach customers
Correct.
pointedly. How
Great.
can we
Great. Great.
apply in that way, sir? That's the
Correct. Correct.
main purpose for joining this course for me.
Yeah. 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 I got your totally got your point, and this is a very good thing actually. That you want to correlate this with your work environment, and you can do actually. And this is a real life example, guys. Okay, this is a totally real life example apart from your theoretical knowledge. So consider, do you have historical data of whatever you are doing, like calling
Yes,
this
sir.
customer?
I don't know whether I can share or not, but our company have nearly 5 lakh data, contact data of
Right.
target customers. They are struggling, sir, to find the customers who can be part of taking loans.
But
Yes,
yeah,
sir.
you should not be sharing this data to anyone out of your
Yes,
corporation.
sir.
That is for sure. But yeah, you
Yeah.
can do one thing. You analyze your data, like whether that data contains any personal information like age, location, those data you have, right? Customers, I'm talking
Actually, no, sir. Location we have location, designation, phone number, name. I think we can draw age through different websites if possible.
Yeah, so this is the first step. This is the first initial step you need to do. You start gathering the data. You need to explore what is your problem now. What is your problem? You are not able to find which audience to or which customers to reach out. That is your problem.
Actually, yes, sir. Exact problem is that we have 5 lakh data, 5 lakh contact details, sir. If we give it to the telecallers, they're on daily basis, they try 100 numbers. For suppose from 9:30 to 6:30, they dial 100 numbers if we think. But we
Okay.
are able to reach only 20 responses. Means that could be anything. Like they need loan, they don't need loan, just someone who lift the call.
Okay, so
We
one suggestion from my end to you, you start collecting the data. Those who are responding, start collecting their data. Maybe like more the data, more beneficial it will be for you, like age, location, or any other details. Those who are not responding also, you gather that data, then you do an analysis.
Okay.
What is the average group of age, like using our statistical technique? What is the average of group of age? Those who are not responding. What is the average group? Those who are responding.
Okay.
What is the common location from them? Or like for an example, because I don't know your data, just for example, I'm saying, what is the
Yes.
most
As is like even like we don't have to have that much of data, like name, age, date of birth, like the location and all the stuff. So also we can do all these things, right?
all these things on what? If you don't have the
Like
data,
no. Like I'm asking that for example, like in my case also are the same thing. Like I do have the members' names and all those. Like even I do have the registration numbers and all those.
see, if you have
So
date of birth, you can calculate age, right? From there.
yeah. Like I
So
do have that age stuffs also. I do have that age stuffs. Like I have like for an example, like if one American citizen was there, like if he was coming to my project, I'll have an A to Z information about them, like including the registration number, including the properties, everything. So with that, like, how can I play?
Play the first step, guys. That's why I forgot the name, but yeah, your case and your case. First of all, you first focus on data. Try to understand your data. That is a really basic step. Instead of going to this, what we are learning, understand your data first. Which type of data you have, numerical data you have, or categorical data you have. You know what is numerical and categorical? Like age
Yes,
is
sir.
numerical, right? Category means
Excuse me.
they are
Excuse me,
gender.
sir. Yes, yes. Okay, got your point. My question is, now we are studying data science course. There are different kind of roles in that. Data analyst, data scientist, data architect, and AI performer. Is that there is so many
Right.
roles,
Correct.
and with the data we are going to calculate some beneficial thing, and we are going to give us the output. This is the perform for anything, any role, right?
Right.
And my question is, we are doing other, actually my question is, we are learning statistics now, and from the data analyst to the AI performer, do all the persons have to learn and give the output, or the data analyst are just retrieving the data, preparing the data, and they are giving to the superior person who was working
Correct.
in that beyond that role, they are giving calculating and taking the decisions. We have to do this through the statistics. My
Correct.
question is, do the data analyst we have to effectively that I'm just asking the 100% effortness or the skills do they need, or the basics if they need, mean is it okay?
So see,
To understand the information given by them, we need to learn all these things.
right. So Divya, I got your question, but you guys are asking me this question because you are, starting phase of this. Once you do this project, no, I think this will make more sense to you. Once you complete this module 21, we have an end-to-end knowledge what you are doing, because that time from data gathering to data processing, using this statistical approach, using the visualization technique, using the machine learning algorithm, you will do everything in one project.
Okay.
There you will get a complete idea, because I don't know your data, to be honest. Even if I'll say this to you, okay, you do that, that is also not beneficial for you. Once you understand the flow, the steps, see, these topics also, they generated based on this. See, first what we do, first we learned about Python coding, because this is what we need in every stage, right? So Python coding we understand. Then we understand how to store the data using pandas, using SQL, using MongoDB. Next stage, so initial stage coding, then understanding and storing your data, then analysis purpose, you are understanding statistics. This is the so you are in the third step now. Then we see fourth step, exploratory data analysis using visualization your data. Okay, then you can create application and those development knowledge in next sessions. Then again next session you can use machine learning to solve the problem in your work environment.
Yeah, got it, sir. And one more thing, that roadmap to somewhat Python or any languages, it give the roadmap for that language or anything, SQL or Python somewhat. In that it shows the lots and lots. Beyond that, what we have covered, it shows too many things in that Python.
Right.
Do you have, if you have learned Python, you have to learn all those things. Then only you can able to 100% completely that those languages or somewhat that. But
No,
here
see,
I got that point.
What is the extra thing that you saw here apart from this?
Yeah, I have saw that, sir. Wait.
Okay, do one thing. Whenever you see a new thing, that there is a chance that you will forget, write down somewhere. Okay, and because in this way you can, because this is not end, guys. Okay, this is just starting. From the beginning of the session, I'm telling you, this is just starting. This is just the front door. Now the world is in front of you. So obviously you don't know nothing, to be honest.
Sir, that I'm having that screenshot for Python.
Tell me what is not what is there which is not here.
Shall I share my screen?
Yeah, sure, okay.
I'm using my phone now.
No worries, that's not a problem.
That here, sir, that I have get this roadmap for Python.
Oh my god, what is this? This is something. Okay, Python, they have made a mind map. Do you know what is a mind map, guys? Please search. Okay, what is mind map?
Is it like a flowchart?
Right, like it's like to memorize the ways quickly. Mind map. Okay, so this Python basic syntax, variable and data types, conditional statements, we all covered this, right? But the name is
Yes,
different.
sir.
Type,
That
expectations, functions. Oh, I can't see actually. Can you zoom bit? Zoom.
yes.
What is the right? List, tuples, sets, dictionaries. This we covered, right? What else we have?
Yes, those we are covered. The Django, Flask,
Django class.
Pyramid.
See this pyramid, right? Pyramid, and yeah, this is the next level. You are going to have this. Okay, but here see this Django, Flash, and all these are the development. You can understand in this way. Development environment. Like if you want to develop a web application using Python, I'm saying web application. That means what? You are creating an application. There you use this Django Flash. It's not yet covered.
Okay.
But here, in this course, we are not going to use the Django. I think we'll use Flask and your Streamlit. These two.
No, I'm not complaining or tell
No, you are
anything
not.
about that syllabus and all those things. I'm just through this, I'm just understanding the way of that structure. We have 21 modules like that. What we need, we are taking that only, like the way I thought. In every language, every courses, we have too many things. And just
Correct,
before
correct.
you have
I
told me that.
See, I got your point. I totally understand. You're not complaining or anything. But what is this? What I'm explaining to you? What we are seeing right now, no? You will see this every time in your whole career, PS career, new things. Okay, but by completing this course, you will get an understanding. If you'll see a new course, how to adapt that feasibility or that capability, it will come to you. So if you'll see what is Django, you go to Django official document and you can able to understand that.
Yeah, it's just the kickstart. I have completely accepted that we have started the statistics, and I'm just very hard to learn all those things. For that, what I have did, I go to that IIT videos. That statistics for data science, there is that course when they have players. They are teaching in a very initial way, from the scratch. They are teaching. Okay, time taken, it's okay, it's not a problem. We will learn like the way what I learned like the way I thought. Okay, I understood that. My question is that in that module we have what we need. That is the thing in that we have like the way I thought.
So what you need, that also like not like it is not possible to cover or create any what you can say, create this kind of sessions and the complete list of that is not enough.
And my question is that data analyst should know the basics. I accepted, but that inferential data, they have told the descriptional data and the inferential data. With the help of descriptional data, we are creating the inferential data, giving suggestions or the predictions we are giving, right? Correct. Data analyst give that predictions or the superior to the data analyst. That AI, that architect, what the roles they have, they will give the inferential statistics to that client
data
or
scientist.
somewhat.
data scientist.
Yeah. That's what my question is. The data analyst should give the inferential statistics.
Introductory part, yeah, like kind of what he say.
Yes, just the conclusion or the prediction. Do the data analyst will give the prediction or some other will give the prediction? This is what
prediction will be given by
asking.
data scientist. Data
Okay.
analyst prediction will be given by data scientist, because you are going to use machine learning algorithm to predict.
Yeah. That's what I'm asking, because we are the just very basic learners. Now that we can't able to give that high much conclusions or what, we are not that much excellent in that. So that I'm just asking, the data analyst will do this or not? That's it.
No, it they can do, but they will do it at initial stage. If we'll go one step further, that you are saying like the upper management, you can reach out to the upper management also, but with DS knowledge. If you have machine learning knowledge and all, you can go to them and you can say like, okay, if you implement this algorithm, it will predict this outcome to you.
Okay.
So that you can do.
I just want to clear that.
Okay.
Just want to clear that.
And good thing that you are going external videos, that will be really beneficial to you. Okay, so that is also a good thing. If you are doing that apart from your BJ schedule, I think you are going to get the reward.
Yeah, sure, sir. But the time is very complex.
That is a problem.
Thank you.
Like for working guys, I can totally feel that it is a totally problem.
Thank you.
But but what to do, because this is enormous opportunities, guys. If you can't imagine in future you are going to be in demand. That is one thing I can send you. Like people will reach out to you if you have the required knowledge. Okay, so if you have the required knowledge and if you have the ability to explain your work, people is going to reach you. You need not to worry about the job and all, because scarcity is already there in the industry. People don't know how to use AI. So even if now what happens traditionally, we have some management and senior people, we always report to them and all. We need to forget that part. Okay, if you want to use AI, everyone needs to learn, from the manager to the smaller positions. Everyone need to understand AI now. AI and prompt. Okay, so we should be opening to learning every time.
This course, is it possible to build a application type of thing and we dope data and we get and we get.
I got your point, but for that one you need not to wait for the end of the course. That project one I was talking, right? You'll get a mail.
Yes.
You are going to create an application and you are going to use YouTube's data or Twitter's data.
Okay, and we will get the exact customer who are eligible for loans, not like that. Who can be the target customers? We can find it out through that.
So as of now, the target customers will be your LinkedIn audience. Okay, that you will showcase that your application to the broader audience. But if you see this in a corporate way, this is kind of analysis that people are doing using YouTube data. The companies, suppose you are running a channel or any music industry, you want to know how many likes, how many videos, how many comments, or whether you got a positive comment or negative comment. So those things also you can do.
Okay.
Okay, but you need not to wait to complete the whole course. In between, I think you will get one module. I'm not sure why they are not giving you. I'm not sure, because once you get that, maybe.
Sir, is there any other supporting explanation for doing project, or it will be like in this section
Totally
only?
no support. I was trying to support, but I got a call from the technical team. They said like, please don't help by giving the code to the people, because I provided code also. They said like, this is because this is also making sense. You need to learn how to learn yourself. That is also one important thing here that we all are missing. So even if you get any support, I will tell you how to complete that code on your own. I'll guide you on that part. No worries.
Okay, sir. Thank you so much.
From this 11 to 11:30, if we get the project, we'll discuss on that part. I am not going to, I'll try to help you out to learn on your own. That's what I'm going to do.
Okay, sir.
So Ashish, first, when we get the project, first let us try to understand what we are doing in the project. And then if we are requiring some explanation, then we will reach out to you.
Sure, definitely. So this 11 to 11:30 we'll keep only this for this Q&A session for you guys only. Anything you have, because this is also new thing for me also. I am not an super expert here, guys. Okay, so I am also like you learning. Just the difference is I started a bit early, 2.5 years early than you. That's the only difference. Here I'm also learning about AI because this is totally new. No one knows. Okay, that AI, that AI prompt, how to develop AI code and all. So that you are going to see in the module 10, I think. Not module 10, module 11. I think they are waiting for module 11 to be completed, maybe. Because in module 11, you will have an understanding how to develop an application, how to write code in Python to create a new application for yourself. I think maybe they are looking for this session to complete. So here we will use the IDE and we'll sit together to develop an application, end-to-end application. Let's see that. Okay, guys. So if no questions, then we'll wind up the call. Let's see you guys tomorrow. Okay.
Okay,
So,
sir. Have a nice day.
Have a nice day, guys. Bye.
Thank you.